Let's take a look at really quickly at number 1, 2, and 3. First of all, number 1. So first, the vertical angle theorem tells us that these vertical angles are congruent, so x is 61 degrees. Next, the corresponding angle theorem tells us that these corresponding angles are congruent, so y is 61. All right, let's move on to number 2. So because these lines are parallel, these corresponding angles are congruent. So by the corresponding angles theorem, 8x is equal to 96. Dividing both sides by 8, x is 12. What about y? Well, for this angle, we could either use the alternate interior angle theorem with 96 or the vertical angle theorem with 8x. So using the vertical angle theorem, 11y plus 19 is equal to 8x. And x is 12, so we can solve for y. Y is 7. Or we could have used these two angles, which are alternate interior angles, and the alternate interior angle theorem to show that 11y plus 19 is equal to 96. And again, y is 7. All right, finally, number 3. Let's find x and y and state the theorems that we used. We might start with the consecutive interior angle theorem. These consecutive interior angles must add up to 180 since these lines are parallel. So the sum of these two angles is 180. Distribute the 6. Combine the 42 and the negative 18. Subtract 24 from both sides. Divide both sides by 12, and y is 13. All right, what about the x value? Well, we could either use the linear pair theorem and add these two up, set them equal to 180, or we could use the alternate interior angle theorem and set these alternate interior angles equal to each other. And I think that's going to be a little less work. So by the alternate interior angle theorem, 8x plus 2 is equal to 42. So 8x is equal to 40, and x is 5. All right, that's it. I hope this helped for numbers 1, 2, and 3.